Okay, any second now.
Okay.
Okay, you're on.
Well, hello there, Astro freaks, stargazers. My name's Ronnie Heron, proudly the host of the following vlog podcast you're going to see that's giving me, this retired radio broadcaster, a slow but sure late in life education about that vast cosmos surrounding us. Welcome to the SBAU Astro Hour. It's a weekly online Zoom foray into cutting edge cosmology and astrophysics for the Santa Barbara Astronomical Unit, one of Southern California's longest running astronomy and telescope clubs. We're headquartered up at the beautiful Santa Barbara Museum of Natural History in Mission Canyon, where we hold our first Friday general meetings, though not this next month, and our second Saturday night time star parties outdoors. Find out about us at sbau.org, okay? And if you can not join right now, we're going to get you sooner or later, but you're fascinated by this stuff as I am, then sit back and enjoy this 227th program into our fifth year of the Astro Hour. This week, we're going to talk about the night sky, check out the handful of planets that are up there, plus the Beehive and Hiatus clusters. Saturn's big moon, Titan's going to transit the ring planet in just a couple days. The first quarter moon occurs midday or a little past, with our satellite about 40 degrees in the sky, in the southern sky. Something about a dual disk structure of galaxies, like our own Milky Way, and using the Webb telescope to look at them. Ooh, there's a shark out there in Cepheus constellation, and it's a nebula. And we're going to get some great looks at these incredible space photos just taken by the largest camera ever built and released by the new Vera Rubin telescope. Let's meet the gang. Thought we were going to miss you, Jerry, today. Jerry Wilson, president, is commander of the Starship.
Good morning.
He's either back in good graces with Southern California Edison, or you're running your generator.
No, they didn't follow through.
Okay, so we didn't have to fall on backup. He's married to Pat Forgy, a big supporter of her husband and of our club, as
Good
is
morning,
Chuck
Joyce.
McPartland. He's not married to Pat Forgy, he's married to Pat McPartland. Chuck is our outreach coordinator, and he's got it down. We got the best of everything. We got Tim Crawford. He checked in early today. He's married to Karen, telescope expert, resident lens specialist. Also joining us, editor of our monthly newsletter and former Westmont College science guy, Tom Whittemore.
Morning.
Now baking his brains out with sourdough, and he's married to the lovely Maureen.
Just pulled one out.
Huh? What'd you say?
Just pulled a red 5 out of the oven.
Yeah, well, we're all looking forward to Christmas when we all get one. We know that. Bruce Murdoch is with us on his cell phone, it looks like, but that's all right. He's married to Bonnie and president of the Santa Barbara Theater Organ Society. Before we do the cartoons, anything coming up special other than the big meeting? And you can include that, Mr. Outreach. Chuck, you want to?
Well, tomorrow night is Telescope Tuesday at Community Rail Marketplace, weather permitting.
Right.
Then 4th of July at Refugio State Beach, and they have a group of families that get together every 4th of July, and they've gotten 15 campsites, and they usually have a little impromptu 4th of July parade while we're there too. And then
Right.
Saturday's Kachuma. We start off our Kachuma Lake outreaches. And our monthly meeting, instead of being the first Friday, has been moved to the second Thursday because of some museum events needing Fleischman. But we're going to have Mr.
Jerry's godson.
Yeah, Jerry's grandson, who's a chief pilot of the helicopter on Mars. He's going to be giving a talk, so it should be pretty well attended in Fleischman Auditorium at 7 p.m. or 7:30 p.m. 7
Right.
o'clock for the planetarium show, 7:30 for the talk.
Right. We have a little half-hour pre-show of ad lib fun, and His Honor the Mayor of Santa Barbara, Randy Rouse, is going to join us. And it's not your grandson, Jerry, it's your godson.
Right.
I think you have regular granddaughters and grandsons, don't you?
Grandsons, too.
How much of your family besides Pat do you think will come up for that?
That's
Well,
a pretty long trip.
All right, we'll
I
have
don't think one's
we'll have
2,
you there.
5. I
We'll have
don't
you there
think
in
they're
the front
interested.
row. Did I introduce everybody? I guess I did, didn't I? Let's go to the silly stuff. You did get some to us, and we got a regular meeting going here, gentlemen. Fun stuff on the cartoon side. We've exhausted Larson's Far Side. Oh, this is new.
I haven't seen this, yeah.
Being sucked into the black hole on a big screen TV. Oh, I see the black hole.
It's a photo exhibit. It's a black hole over there.
That works every time. What must life be like on a planet going around a black hole, if there are
Well,
any?
time passes very slow.
They think there is a planet. Have they seen one, or do they know one's out there?
I
we
don't
go.
know.
I had to
That
transfer
would be
this.
very tough to see it.
Couple guys in a sailing high in a hot air balloon. One guy says, apparently one of them, this would be the professor. All right, this is the spot. You may now release the bowling ball. And it falls. Very good. Now, can you describe what just happened? And his student says, well, the ball fell to Earth, Professor, accelerating at 9.81, is that miles or meters per
Meters.
second?
Meters.
Meters.
Second
Where?
squared.
All right, then it smashed into Dr. Monroe's car. But I'm afraid I can't see what we've learned in this experiment, Professor. And the prof says, well, we've learned nothing, but apparently, hopefully, Dr. Monroe's learned not to park in my damn parking space, for crying out loud. Works every time. You could have tried the feather at the same time. Okay, now this, I've thought about every one of these almost. There's an infinite number of planets. You want to read some of these, gentlemen? Starting with you, Jerry.
Oh, giant planet that orbits so close it's actually rolling along the star's surface.
Okay, typical
Goes here,
exoplanets.
hot Jupiter way far out. Okay.
I don't know if it's on there, but they say there's a planet made of nothing but diamonds, like compressed carbon or
Not of
something.
nothing but it has them in its crust.
Yeah.
All right, well, let's jump around a couple. You guys just take one. Bruce, read one.
This has to do with mini Neptune, planet that could be habitable if there's a form of life that hates water but loves acid and being on fire.
All right, Tim, what's your favorite on there?
I've been answering the fellow from India here, so I haven't been paying attention.
All right, well, Tom Whittemore, pick one of the exoplanet systems that may exist out there.
Okay, how about planet that may actually be in the habitable zone, according to a very optimistic modeling paper by some desperate postdocs?
Chuck, grab one more.
Earth-like data artifact. That's a good one.
How about
Well,
this
I got-
one? Planet whose surface may host conditions suitable for rocks.
Yeah.
That would be Venus.
I just wonder, why a science fiction movie hasn't been made about aliens landing here during the how many godzillions of years the dinosaurs ruled and might have gotten eaten by a T-Rex. Spielberg's got to work on that one.
Make for a short movie.
Yeah.
Because we've only been here a minuscule amount of time compared to that vast Pliocene and Jurassic.
Yeah. Depending on how you count it, we've been here about our species roughly 1 million years, or Homo sapiens about 100,000.
Yeah.
The way I've heard it spoken, if the Earth has been here for 24 hours, in other words, one day,
Oh,
we've been here in the last 5 minutes.
yeah.
Yeah. Well, I
Okay.
guess that was the beginning of 2001 Space Odyssey. Okay, somebody's saying nothing inside the telescope as it's pointed down. You want to read that to us? I don't
Says,
see
don't make me tap on the no bird watching sign again, Professor Brown.
it.
See, they're looking down at the birds.
Can the rest of you read the words? I can't see them.
It's
Oh,
pretty
yeah.
washed out, but it's there.
Yeah.
Okay. And here's a couple of talking stick figures. One's a lady and one's the guy. And she says, shining laser pointers at planes is a federal crime. It's incredibly dangerous. And he asks, oh, because it can blind the pilot? She says, well, that's one reason. But the other reason is Chuck's cat may just leave his lap and take that plane down with that little green speck on the wall. Do you do that, Chuck?
With a green laser pointer, it's much too powerful, but they will kind of chase a red laser pointer.
Yeah.
Greens, they don't see green.
The green is too powerful. I wouldn't want to use it with them.
Yeah.
Oh, I see. It might blind the cat. Here's
Yeah.
a hot day in the Andromeda Galaxy, 3047.
Hmm.
Real hot.
So a spaceship has crashed here, and just off scene, an alien is licking a cryo sleep chamber 13 popsicle.
What is the thing it's not a laser. Didn't bring it down with a laser pointer. What is that he's holding?
That's a popsicle.
It's one of the crew members of the spacecraft that was in hypersleep or whatever, and the alien's treating it like a popsicle.
Oh, I see. Okay. Open the pod bay door, Hal.
Yeah.
Yeah.
Got it. Got it. Okay. It's fun to get these that you didn't get early, and so you just sort of caught off guard and initial reactions. Well, the night sky apparently we only have some planets available. Is that correct? Did I read that right from your talking points, Chair?
Yes.
You could see them.
You're going to tell us where the ones that aren't being seen are? There we
Most of
are,
them.
Early morning.
with a concave horizon. Gives us more night
Yes, this is,
sky. Love it.
excuse me.
We
Yeah,
have
the morning sky is dominated here by Uranus and Venus. They're in close proximity, very close to the Pleiades.
Pleiades.
Yeah.
Hmm.
They're within 2 degrees of each other. So they're almost within the field of view of a small telescope. The right eyepiece, they're in the same field, the right field. Mercury is
Evening sky.
It's
Mercury
evening.
is at the evening
Yeah.
sky. Let me just see if there's another point we wanted to make. Of course, this is a asteroid up here. I don't recall which one. But moving on, this is the evening sky, about 8 o'clock. It's not quite this dark at 8 o'clock, but it gave me a good separation from the horizon. Mercury is here. Mars is up here. Mars is not a particular dramatic object right now. It's very far away. I think it's about 7 or 8 arc seconds in diameter, which is pretty small.
Mhm.
But it's orange.
Yeah, it's orange. It's not the bright red it sometimes is. Mercury is in the region of the Beehive cluster, which is a very large cluster. Mercury is now, it's 46% illuminated. A week ago, it was 50, and exactly, but I forget what they call that. We'd call it the last quarter Mercury, but it's
Dichotomy.
dichotomy. That's it. Thank you. Now, the Beehive cluster, M44, is also known as the Praesepe, which is Latin for manger, cot, or crib. It's an open cluster in the constellation Cancer, and it's one of the nearest clusters to Earth. As a matter of fact, I think it's the second closest cluster to Earth. The age of that cluster and its proper motion coincide with those of the Hyades, not hiatus, but it's Hyades, which is also a large open cluster. And that cluster is the core of the head of Taurus.
Hey, Jerry, may I make a comment?
Go ahead.
Yeah, do you see Castor and Pollux there, Gemini?
Mhm.
Notice where the sun is.
Right
It's in
there.
Gemini. But if you follow horoscopes, July the 1st or so is Cancer.
Yeah.
The
Procession has gotten the better of
precession has
astrology.
gotten, yeah.
Well, astrology also claims there's 12 constellations of the zodiac, and as we know, there are 13.
Right.
So when you make something up, you should change it a little bit out for the millennia.
Yeah.
But they
Yeah,
have
it's always nice to have wiggle room when you don't have data.
Right.
Right.
Right. So I was born in July and I'm supposed to be a Cancer. Clearly, I'm a Gemini.
I was born in July and I'm a Cancer.
By the way, Jerry, happy birthday.
Oh, thank you.
Yeah. It was last
Really?
Friday, right? Last Friday, Jerry.
Yeah.
Yeah.
Oh, wow.
Set off a Roman candle early.
Yeah. No, we stay away from flame things.
Yeah.
Are you guys are you gentlemen being kept awake at night by the early pyrotechnics?
No, no one's
Sometimes.
setting off stuff out here that I hear.
Well, it finally quit at midnight last night, but every so often.
Oh, you've already got it. Wow.
Oh yeah, we
Oh.
did too. Can I make a comment from our friend from India here?
Yeah, go ahead.
He said that they have predicted, I don't know who they are, but some calculations were made, and they think the T Corona Borealis is going to go off from November 25th to January 26th. So,
Interesting. I
any
keep
any
looking.
comments you want to make, go ahead. I just told them that, hey, the best way is just to look.
I keep looking, Tim, with binoculars, and
Yeah.
nope,
Nothing yet. Yeah.
nothing yet. Yeah.
Well, the neat thing is, space weather now has a running tally of what the magnitude is now and what it was the day before.
Okay.
And about 2 days ago, it popped up to 9.9. It's been down at like 10.2.
Uh-huh.
It popped up to 9.9, and I thought, okay, here we go. But then it popped back down again.
Yeah, it's hard to really know. Somebody I think in India did some calculations, and the math told them these are the probable dates but I just said, hey, we've been just monitoring it, and the best way
Well,
is just
I
to
don't know
look.
if it's in India, but there's somebody that's been monitoring the brightness levels for years and thinks they have an orbital period for the pair.
Oh, I see.
And they think it goes that it's the outbursts are somehow related to that orbital period. So he gave a couple of intervals like the ones you're talking about,
Oh, interesting.
but
Okay.
who knows?
Well, there you go, Astro.
Suppose they could do the same thing with Beetlejuice.
That's a totally different thing.
Yeah.
Right.
Oh,
Yeah, tell everybody what we're talking about. There's a periodic nova, and it popped off last time, I think in 1947, was it?
46.
46,
Yeah.
okay. And there's a pattern of brightness change before it finally erupts in a full nova. And we're starting to see that pattern of brightness change now.
Mhm.
Although the
We
times,
saw it. Yeah, we saw it last year. So we started saying any minute now.
yeah, any minute now.
Yeah.
But it's a cosmic minute, not a
Yeah.
wristwatch minute.
Tom Totten is famous for saying it's midnight tonight.
After midnight.
After
Yeah.
midnight, yeah.
Yeah.
And it will definitely be after midnight.
Yeah.
Now, this is a close-up picture of M44,
Mhm.
which is a large, bright, open cluster near the ecliptic. It's often visited by planets. This week, Mercury skims near the group of young suns. The
If
height
you rotate this about 90 degrees counterclockwise, then you can see the beehive. It's that kind of V-shaped bit in the middle.
this thing,
Yeah, the old-fashioned conical beehive.
Mhm.
okay.
And the bees flying around it are the other stars.
Mhm.
Huh.
The little triplets of stars flying around are the bees, are they not?
Yeah.
Yeah.
There we go. That was kind of it.
Yeah. At modest power, I usually see a bunch of triangles in this guy.
Yeah.
Uh-huh.
Yeah.
I've noticed that when I see it, the spotting feature for me is a whole bunch of doubles.
Okay. Mhm.
this is the extent of the beehive cluster?
Yeah, the bright stars.
Yeah. In a dark
This is
sky,
bright.
Ron, you can see it with your eyes.
Yeah.
Ron,
I was
it's,
gonna say, yeah.
it's a
It looks like it doesn't-
binocular object. It's
Easy,
really
easy
huge.
binocular. Yeah.
But
Yeah,
you'd think
with
it'd be
averted vision, it's visible as a fuzz patch, and the ancient Greeks used it to predict the weather because if
Okay.
you could see it, it probably wasn't going to rain the next day.
Oh, that's
Yeah,
a good
one of the times we were at Kachuma, I could see it naked eye looking straight at it.
Yeah.
It was
Mhm.
amazing.
Wow.
And it's big.
This
It's
too
big.
washed out.
No, that's good.
No,
That's
it looks good. That's the
Okay.
Hyades, though. It's not the
So
beehive.
this is the Hyades cluster.
Oh, interesting.
This is the very bright star Aldebaran at the eye of
The
Taurus Bull,
Mhm.
and these are the stars around it. Messier did not give this a number. It was too big, I guess.
Mhm.
Don't know.
Yeah, and 1647 is wonderful on a small telescope. It's a
Oh,
real
up here?
nice open cluster. Yeah, it's a beauty. I like that a lot.
Mhm.
Where is that, Tom?
the yellow
But-
circle.
The yellow
Yellow
circle
circle.
tail.
Oh,
Right up
okay.
there.
Yeah, it's a small refractor.
Okay.
It's really nice.
Now there's a star in the middle next to Aldebaran right here, and it's got theta 1 and theta 2, and it's
Mhm.
called the theta, and it's a double cluster, a double star.
Mhm.
Huh.
This is a picture of that. This is Aldebaran.
Wow.
and this is the theta.
Mhm.
And the theta has a nice color contrast, yellow and blue.
Mhm.
Matter of fact, pretty much most of the stars that are color striking like this are yellow and blue. A few of them, I mean, there should be one that's really red and blue, but I've not seen one yet. Just yellow and blue.
I
You get
think
three of them, you get red, white, and blue.
Ras Al Gethi, I think in
Yeah,
Hercules, the head of Hercules is supposed to look that way, I think.
Yeah, yeah.
Now, the yellow star is like our sun. It has a surface temperature about 6,000 degrees Fahrenheit, well, what, 8,000
Kelvin.
degrees Fahrenheit,
Mhm.
5,800 degrees Kelvin. And this is a blue star, which is much hotter.
Mhm.
And blue stars can get up to 50,000 degrees surface temperature. I don't recall the surface temperature of this one.
Mhm.
But there's a lot of new blue stars here. It's a very dramatic and open cluster.
Yeah.
It has
Jerry,
been-
50,000 Celsius or 50,000 Kelvin or
That's
It doesn't-
essentially the same.
Yeah, it doesn't matter.
okay.
They differ
The
by
difference-
400, yeah,
Go ahead, Bruce.
272 degrees.
Yeah. Out of 50,000, who cares about 300?
Yeah.
Yeah, exactly.
Now, this is a map, a very interesting map. It shows the closest star clusters to the Earth. So this one is our sun is right there.
Mhm.
And out here is the Hyades cluster.
Hmm.
Um,
That's how many light years?
100.
Okay,
yeah,
so
not too far away.
Mhm.
Oh, I meant the whole diagram.
Oh, okay.
well, how far out is the Hyades? 100?
Yeah, 100 parsecs.
Oh, 100 parsecs, so it's 300 light years.
Yeah.
But it's about 100 for the Hyades.
Parsecs are 3 light years. Okay.
3.26.
Right.
What's
But who's
the
counting?
what's the strange
The
light?
Hyades are about 33 light years away, about 10 parsecs, it says here, and it's estimated to be 625 million years old.
It's young.
What is the big light brown surrounding supposed to be?
That's the density of stars, apparently.
Oh, okay. Do we know which direction the center of the galaxy would be in that diagram?
Um,
Probably toward Ophiuchus. So off to the right.
Okay.
yeah, Ophiuchus dust cloud right there.
And
this is
Scorpius, and those other things. So that's toward the center.
Mhm.
But well within the center of all that is our local group of galaxies, right?
No, this is stars in our galaxy.
I thought this was the nearby star clusters.
No, this
Yeah,
is a
nearby stars. Yeah, they're in our
nearby
galaxy.
stars. Yeah.
Okay, got it.
Now, the coma showing there near our sun, is there some star that's illuminating it?
That I think that's just a nebula object or a galaxy cluster that's in the background.
Yeah, that would be way in the background.
Yeah.
I don't know why they stuck that in
Name
there.
things here with the blue names, those are stars.
Mhm.
They might have meant Coma Berenices, I think, not the Coma
yeah,
cluster,
Oh, okay.
because that's a
Very nice
nearby
to pull.
cluster
Yeah.
of
Oh,
stars.
Oh, yeah.
So anyway, this is 100 parsecs. And so the Hyades is about here. It looks like in their view, it's about 40 parsecs. The blurb I got said it's 33, but that's okay.
That sounds close. Yeah.
Yeah.
Well, that's
That's
33
astro.
parsecs is still 100 light years. So
107.6 light years.
Well,
Okay, go ahead.
even though I'm sorry, but nebulas are one thing, gas clouds,
Yeah,
star clusters, we know what that is. Is it possible there could be 2 of those together occupying the same space?
yes,
happens
absolutely,
commonly.
because that's where the star clusters come from.
the Lagoon Nebula.
Yeah.
We'll see that shortly.
Well,
Mhm.
most star clusters I see don't have gaseous large fields around them. Maybe I just don't see it.
No, that's a stage in the star development. When stars form out of the gaseous cloud, they're embedded in the cloud. When they turn on, if they're hot and bright, they're very quickly blow all the dust away, and then you just have the star cluster left.
M42 is the beginning of that sequence.
Right. Okay, this is looking around 1:30 in the morning tonight or tomorrow morning. Shows Neptune and Saturn.
Look at that. Saturn's already trying to work its way into the nighttime sky.
Really?
Yeah, down at the bottom there, 6 o'clock.
Yeah, Saturn and Neptune here. I got distracted by Pluto up here. But so dwarf planet. But Saturn and Neptune is not visible to the naked eye. Saturn is visible to the naked eye. So this is in the east. So they're just rising at 1:30. And that just tells you where to look for Saturn because the next topic is Saturn.
And coming up in September or so, it'll start to be showing up at the kind of at the tail end of our star parties.
Okay.
Oh, nice, nice, nice.
So this
Oh,
is a go
I'm
ahead.
sorry, dumb question time again. We can see upwards on Saturn's rings as well as downwards.
At the moment we see upward. Well, it depends on which way your scope tilts Saturn.
Well, it tilts in it. Is it on a similar tilt to Earth? 20-something degrees?
Good question.
It's 20 something degrees plus its orbit is tilted a little too.
Yeah.
And has a six-sided North Pole.
Hexagonal North Pole. But that's why we pass through the ring plane because of the orbit tilt that
Yeah.
Chuck just mentioned. And it was last March 25th or 20th or something when Saturn was on the other side of the sun. So we didn't photograph the event, but it passed through the rings plane. We passed through the Saturn ring plane so that if you looked at Saturn at that time, you would just see the ball. You would not have seen the rings at all.
How long does that last?
It was very quick. The rings are only 35 feet thick.
Okay, so we see it edge on and then it slowly comes back.
Yes.
Yeah. And then you're looking at the other side from what you were looking for before the disappearance.
Does anybody ever take a video of that? You would think you could see it materializing on.
I would think someone has, but I haven't seen it.
I noticed another black dot on Saturn. It's about 3 o'clock.
Yeah, that's Mimas. It's washed out here, I think.
Oh,
Wow.
But that would be hard to spot, I think. That'd be tiny.
Listen, gentlemen, before I let you go on the next topic, I had a 5-letter word in the crossword puzzle that I didn't know. It said brightest star in Orion. And Vega wouldn't fit, and neither would Sirius. What is the 5-letter brightest star in the Orion Nebula? Or the
Rigel.
Orion. What is it?
Rigel.
Rigel.
Rigel?
Yeah.
Yes.
okay. Is this one less washed out?
Yes.
Okay. So here is Titan's shadow. Now, currently, the reason this is up here, Astronomy Magazine is pointing out that with orientation we have to Saturn, there's a period here of several weeks to several months long where things and their shadows will both be visible in transit across Saturn. And this is one of those events. You can see Titan out here, and Titan's shadow is on the disk. Can't always see that. This is Mimas. It's actually the moon there, Mimas in front of the disk. Tethys is out here, and Enceladus is out here. So this is and this is at, let's see, this is at a special time.
Actually, Mimas is to the left of where it says Mimas, and then the shadow is down below it to the right. So the black dot is the shadow, but it's really small.
I don't
But you
see
can see a bright dot where Mimas is.
I don't see that. Oh,
It's
there.
right-
Oh,
yeah,
right
right
there. I
there,
see
yeah.
it. Oh, it's washed out for me, but not for you. Yeah, Yeah, this is Mimas and that's the shadow of it. Good spot.
Yeah.
Oh, I didn't see that either.
No,
Isn't it Saturn that now has the most moons of all the
Yep.
planets?
245.
Oh, I was wanting to know that number.
And which number, if you count outwards, is Titan?
I think it's 6.
So there's 5 and closer, okay. And it doesn't have an Io, a volcanic little locked in
no,
tidally
it's not that active of a,
It does have Enceladus, which is like Europa.
Okay, all ice.
Yeah.
Got it. Well, that's not volcanic.
Well, it's cryovolcanic.
Well, I'll take that any day over a regular hot volcanic.
Can I just ask another aside question? I kind of
Sure.
miss having Tom Whittemore out at these star parties because he loves star clusters, and I was trying to find a publication here in my library that showed a bunch of clusters only. Does anybody know, is there an atlas for clusters only?
There's
star
a book.
clusters?
There's a book by Webb, I think it is, one of these British clerics that was an observer of open star clusters. So there's a book that's a compendium of open clusters
Yeah,
that's visible in small scopes. It's really old, but so the numbers you get will be bad as far as distances and stuff.
that's okay. Just the listing of them so I can just jump to them. Because
Yeah.
that's what I want. I was struggling. Tom and I were looking at one sometime back about 2 or 3 months ago that was just gorgeous in the night sky. I couldn't remember it. And um, you remember that, Tom, when we were out at Westmont and we had the uh, Andre and you were pointing up to the somewhere, and I cannot remember what it was.
Cassiopeia?
No, it was the other side of the sky.
Oh.
We were up by the dome there. It was just absolutely amazing.
Hmm.
I'll try to remember it. But anyway, it's Webb, WEBB, right?
Well,
Yeah.
I think, yeah, don't quote me on that, but
Yeah, my copies are all in Jurgen's hands now.
Oh, shoot.
yeah. There's also that compendium that was done by the guy in Arizona. That's the 3-volume encyclopedia type series of books on all the constellations.
I had those and got rid of them. Those are really
Yeah.
good.
In each constellation, it would tell you open clusters.
Yes.
Yeah.
Well,
Those
we
are
keep
neat.
scanning new ones, so there must be hundreds of those suckers out there, right?
Yeah.
I might be able to get into my the star atlases, the sky safari, and just kind of go and say it might show you just clusters,
Yeah.
open that up to.
Now,
I'm
there
gonna
are
try that.
clusters, there are things that look like clusters out there, but with their radial velocity measured, they're not in the same position or moving the same speed, so they're not actually clusters. They're just apparent clusters.
Just like the
Okay.
difference between binary stars and double stars.
Yes, exactly.
Yeah. Okay. Well, thank you guys.
Sure.
Appreciate that.
Oh, another
Hey.
fun one is there's a list somewhere you can get on the web of clusters that look like things, asterisms. So there's the Eiffel Tower and Napoleon's hat and all those kind of things. They're
Yeah.
kind of
Christmas
fun.
tree.
The teapot.
Yeah, that's a big one.
Asterisms would be great. And one of the classic one is the owl cluster.
Yeah.
Oh, yeah. NGC 457.
457, yeah. So but yeah, but thank you. I appreciate that. I've been trying to find something that I can take to a star party. A lot of times we have weather that permits only clusters.
Yeah.
More likely a weather that permits nothing.
We got that last week.
We've had that almost every night.
Yeah.
What percentage of old Messier's objects are clusters? Most of
Ooh.
them? Half of them?
I would say
Most of them, I
30.
think, are galaxies.
Mostly are galaxies?
Yeah.
Like
He
say for
started to
instance,
add clusters later, especially obvious clusters like the Pleiades, just to get
Yeah.
elected to the French Academy of Sciences.
and
Wow.
some were not included, like the double cluster weren't included.
Yeah. He did a lot of galaxies and globulars, which are clusters.
I wonder if Stephen O'Mara has something.
Oh, I
Yes,
bet.
he does.
Yeah.
Yes, he has his own catalog. I think I don't remember that well.
Well,
Okay.
Caldwell.
once we get
I
it from
think
you,
it's-
Tim, I want to report 3 pages at least, triplicate.
Okay. I'll find something and I'll report it.
Okay.
The thing is, I'll just bring Tom and have him talk to you. He
Mr.
is
President,
fantastic. Whittemore is absolutely fantastic at under the night sky of finding clusters, and it
Mhm.
just absolutely blows people away. He'll just go over to one, then go over to another, and go to another. It's entertaining. It's
Yeah.
entertaining.
Well, thanks, Tim.
he's got to tend to those ovens.
The oven cluster.
That's right. Where are we, Mr. President, on the sky here?
We're looking at the time frame of the quarter moon.
Mhm.
The quarter moon happens it happens at 1:30 p.m. Pacific Daylight Time, so it's in the afternoon, and it's not up. So
Well,
this is
yeah, it would
What's
be if
that?
it's first quarter.
that's right, it would be, you're right.
Mhm.
So this is at 9 o'clock p.m. on July 2nd, so tomorrow night.
Telescope
night
Tuesday.
after tomorrow night.
Telescope
Yeah,
Tuesday.
Telescope Tuesday. Yep. So here's its relationship to Mars, and okay. So that shows where it is with respect to Mars. The font size changed here, so it threw me off. So this is, we're looking at about 3 or 4 different pictures from the Vera Rubin camera. I mean, the large digital camera at the Vera Rubin Observatory. It's not the
Oh, are we
camera.
starting the pictures right now? Fantastic.
So this is the
This-
Lagoon Nebula down here, which has a star cluster in it. And this is the Trifid Nebula here. And
It's
all the
really
rest of this
washed
stuff-
out. It's really washed out.
Oh, wow,
Yeah.
that's too bad. Okay.
Keep in mind, this sucker is still earthbound. How does it counter that little wave, that little wiggle thing factor of the upper atmosphere?
It's in a great place.
Is that
It's
what it
high
is?
up.
It's high in the Andes Mountains. Okay, so can you see this better?
Yeah, that's much better.
Okay, so this is the Lagoon Nebula here, and there's a cluster in there. And there's the Trifid Nebula, and virtually all of the rest of this background stuff, usually escapes our amateur photography. So
Really?
this is a 3,200 megapixel or a 3.2 gigapixel camera. And this is a
This is just a tiny
10-hour
slice.
exposure.
This is just a tiny slice of that huge image, too.
Yes.
Where is
Okay.
where is M8 on this
There-
one? It's down there in the title.
It's right there, the
Right
Lagoon
there.
Nebula.
Oh, wow. Okay. I have a picture of that, but it shows much more of a lagoon around it.
What's the pink?
Yeah.
Fluorescing hydrogen.
So we're looking at a large nebula here.
Yeah.
Now, this
Okay.
is a super wide angle camera, and they're going
Did we lose you?
graph the entire southern sky, about 2,000 asteroids, if I recall correctly.
In the first 10 hours of observation, yeah, they found 2,100 new asteroids.
Mhm.
And they do that just by determining where they've moved over a period of time.
Right.
Otherwise,
Yeah.
you might think,
Yeah.
They overlay images, and a computer software notes the distance that things have changed, or the way things have changed with respect to other things.
Right.
And also, it's a monochromatic camera, so they take 3 images through, various filters like red, green, and blue. And so the asteroid shows up as, a red line, then a green line, then a blue line. So it makes it easier to find them.
but are they in the belt or are they running loose throughout the system?
Most of them they found were in the belt, but they also found some Jupiter Trojans. It happened to be they were looking in that right direction for that. And they found some trans-Neptunian objects. And this is in the first 10 hours. I mean, They're going to be doing this all night, every night.
Trans-Neptunian meaning beyond Neptune?
Yeah.
Yes,
Out in Pluto territory.
Yeah.
yes, Pluto
that's
was a TNO.
Yeah.
the Kuiper Belt, isn't it?
No. Well, once you get far enough out, yeah.
Right, the Kuiper
Yeah.
Belt is out there.
I wonder how they store all this data. They're talking about gigabytes every night.
Every
Yeah.
night. It's six. I
They're
think it
gonna
was
use a lot
20
of
or
power.
60 terabytes
20, that's the
every
number I
night.
remember. Yes.
Well, I wonder how the pictures would be different from this one we're seeing that the Vera Rubin took and a Webb photograph. Would there be a difference?
Well, yeah, the web is infrared.
Oh, okay. This is just a regular old giant camera, the biggest. You know how big the lens is on the camera?
It's a mirror, 8.4
The,
meters.
the telescope is the lens.
Right.
And
I
hey,
thought
Ronnie, this is the lagoon area we were talking about. This is
Right.
where the gas and the clusters are.
Yeah,
And then-
Ron, I was going to say, Ron, the fact that it's 8.4 meters tells me it was made in Tucson, Arizona.
Yeah. Under the stadium.
That's it. Yeah, been there.
Okay. I heard it was the largest camera in the world. It was like a
Yes.
giant Kodak
It is.
Instamatic.
It's a whole bunch of chips,
Yep.
done onto a planar array,
Mhm.
and they have to be within something like 10 microns, the surface. They all have to be at that level, so they deviate less than 10 microns. So it was really an engineering feat to stick them all on there that way.
Mhm.
They don't have micromanipulators to adjust them after the fact?
No, no, these are the chips.
I know, right.
Yeah, it's a mosaic focal plane of chips.
So if the
It's
pink
not
is
really-
hydrogen, what's the light brown around it to the edges?
Dust.
Just dust? There's no element involved, no gaseous. I
Oh,
didn't
there's
think
probably hydrogen in that too. It's just not fluorescing.
Yeah.
I hear that in your home, most of the dust you find is dead skin cells, but this dust that you see here is not dried skin cells.
Yeah.
It's ground up bits of minerals and rocks.
And Ron,
Like 20 tons a day?
say that again, Tom.
I was going to say, when they point it into Pisces, you'll have fish and chips.
No.
Okay.
Lots of tartar.
Thanks,
Typical
Tim.
tartar sauce from Tom Whittemore there.
Yeah.
All right.
Look
Do you
at
get
that.
paid? Do you get paid scale for these jokes?
I should. They're pretty good.
Fish
That's-
scales.
That's Virgo.
He reminds me of that old line that he's a card and needs to be dealt with. Okay. This is
Virgo.
elliptical galaxy,
M49, I
a
think.
larger capture of the Virgo cluster from Vera C. Rubin.
Yeah.
spirals and
Another tiny
interact-
slice of that first image.
Yeah.
There's a smiley face
Yes.
too. I see the smiley face down there.
Where?
Down
Smelly.
At the
straight
bottom.
down.
Can you move your cursor and point it out to us, Jerry? Is that it? That's a smiley face.
Well, go left. Keep going left. Now, oh, too much. Right. Okay, see the arc there? Just go up and
The
down.
arc.
And there's your arc. There's the two eyeballs over to the right.
Oh, that.
No,
What
well,
was in your coffee this morning?
yeah.
Called having fun with the sky, folks.
Mhm.
I love it.
Oh, but he's got good pattern recognition.
But it's not one of Einstein's.
No, not an
Oh,
Einstein
no.
ring. This is a slice of one of their pictures, but it's centered on the Virgo cluster.
Mhm.
So these are among the brightest members of the Virgo cluster.
And
Yeah,
they're all
that light took 60 million years to get here.
And a tiny little patch of the Virgo cluster, actually.
That's right. Yeah.
Yeah.
That's beautiful.
And you can
No,
see
they're all
all these
galaxies.
tails, stars between galaxies where they've interacted gravitationally as they ricochet off each other and slide by.
And almost all those little dots that you see that aren't bright blue are other galaxies.
Mhm.
Yeah.
Oh, wow.
The blue ones with the spikes are stars in our galaxy.
Mhm.
Oh,
There. And there, one down there, one down there. Those
I
are all
sup-
the obvious ones to me.
if you lived on an exoplanet in one of those galaxies, your sky would have what, about 10 Andromedas, wouldn't it?
There, the
Yep.
distance between those could be the distance between us and Andromeda. These things are very far away, so those distances are very vast.
Mm-hmm.
Oh, are they? Okay. It's not their own little local group.
Someone in Andromeda is looking out with their telescope and they're looking at the Milky Way and they're saying, boy, the skies must be great in that galaxy.
Yeah.
Wow.
And they are.
This is from Vera's scope.
Yeah, Vera Rubin.
Well, you got a triple suck up, I
Yeah,
guess.
it's
There
a
in
nice little combination of interacting galaxies up here.
Yeah, that is really cool.
Mm-hmm.
And these are all this gray is star cloud, is stars that have been thrown out through these interactions.
Mm-hmm.
Wow.
I've
Oh.
seen computer models that say that our sun and our planets will be slingshot out of the Milkomeda galaxy
Yeah.
after they pass through each other.
Now, per our conversation off air before we began, the information from the Vera Rubin, what value is that to us?
It
Pretty
lets
good
us
looking.
search for moving objects, such as asteroids that we may not know about that are near Earth or farther away. It
Okay.
will help us spot comets. It'll help us spot things coming in from out of our solar system. And it'll give us a good data set for mapping our structure of the Milky Way and the outside our universe.
And it'll give us a graphic illustration of how much junk we put into space around the planet.
Yeah.
That's true.
You suppose that meteor,
This
that meteor that came down the other day, was that space junk, or do they know yet?
I don't think they know,
I think-
but speculation is it was not a reentry.
Oh,
yeah,
came straight
they
down.
they have someone showed a picture of a hole in his roof and said this was produced by that, according to the homeowner.
Yeah, I
In
saw
Georgia?
that.
In Georgia?
Yeah, the hole was about the size of a baseball, and
Wow.
I think the object gave a much brighter appearance than an object that small.
But if it were space junk, it'd come in at a steeper, or not a steep angle. This was steep. This was straight down. And that didn't
You know,
usually-
Ron, that's perspective from wherever they took the image. You
Yeah, that
really
can be
that's true
very,
too. It could be coming at you. You're right. Coming from
When
It
they
could be very
deorbited
misleading.
spacecraft, it's really bright and it lasts a long time, a big streak across the sky.
If you watch one of these launches from Vandenberg, which is about 30 miles north of us, it looks like it goes up in the western sky and then it goes down the sky to the south. It looks like it's coming down, but it's actually moving away in orbit.
Really? You can see
Yeah.
that well and that far, President. Wow.
Well, it's a bright object in the evening sky. It's hard to miss.
Do you get the
But think about
sonics?
it. It goes up, it turns over, and then it looks like it's going down as it disappears far away.
Well, you're about 12 miles closer than I am. Do you get the sonic booms, Jerry?
Yeah, about 5 minutes after it
Yeah,
takes
5
off.
minutes later.
I heard the sonic booms come from the re-entry of the first stage.
The sonic boom too. Yes, that's right.
and
doesn't
from the
make-
state and from the rocket going up, because it has to go 17,000 miles an hour to get up there.
I know that, but do they come back at that speed?
At
The
first,
Not
first
at that
stage,
speed, but faster than the speed of sound.
yeah.
and then
They
it
don't
slowed
slow
down.
down before they enter the atmosphere. They use the atmosphere to slow them down.
Oh, they do.
My daughter lives in Vandenberg Village, and she's very annoyed by the rockets taking off up there.
I bet.
She gives them a Richter scale.
What's 4th of July like in her town? Interesting.
I don't know yet. She has only lived there about half a year.
But the
Wow.
sky
Down
might
here,
look
look,
like
there's a
this.
nice, look, there's a nice little ring right there.
Mm.
Oh,
And then
yeah.
there's an Indian teepee with a spot on top of it in the center.
Well,
Huh.
there's a face that's just upwards into the right of that. Those are the two eyes, and then come down and you see the nose.
Yeah,
Is
this
this
looks
Vera
like a
Rubin?
fly's face, the big old
Yeah.
bug eyes and the fly's nose to me.
Yeah,
It's
yeah,
just-
good.
After a
That's a
while, the
good
human brain
visualization.
starts making sense out of it.
And we're still looking at Vera Rubin pictures?
Oh,
This
yeah.
is
Yes.
we're
yeah.
still looking at the first image it took. It's so big, we're just looking at little chunks of it.
Anybody remember what they released to the public? What did all the newscasts run? Which
This
picture?
is released to the public.
This is what we're looking at.
Yeah.
Now, if they took the entire image, you'd need a basketball court sized display to see it all.
Wow.
Well, they-
Wow.
Well, a few
The
8x10.
claim is that they would need 400 4K high definition television screens to display it in its original size.
Good Lord.
Yeah, that's
Well,
amazing.
So not a lot of wallet size and 8x10 glossy is
Yeah.
available.
Now, this is a region, you can see M61 down here. And there was a star here, KO Virginis. So I had another spotting feature anyway.
M49
But
is that
these-
big one there on the left.
This one,
Yeah.
Yeah, that one.
this one. Okay. Oh yeah, M49, yeah. So, and to give it a position, this is M61 here. And near
And M49 just above it.
Mhm.
Yeah, M49 just above it. So between those two things, you can go. So this is M61 and M49. So right in there. And that other picture was from my planetarium software with a lot of the fainter stuff suppressed. But this is a very nice annotated diagram. Structures that we see up there. And these are structures that we're likely to see in with our telescopes and cameras. There's nothing here that's much deeper than that. But the processing brings out these stellar bridges between things. You have to work at getting those things to come out in our amateur photographs.
Plus, even this is a pretty wide field.
Yes, it is.
But do you
Yeah.
suppose some of those dots in there are new asteroids?
Well, way in the
Probably not.
background, possibly.
Okay.
Most of those are galaxies.
Most of those are
Yes.
galaxies.
Yeah, the stars are going to have, like that's a star, that's a star, that's a star. And they will be annotated here with the constellation they're in, and I don't see any other ones.
Wow. Love this astronomy.
Yeah, we're looking at part of the Virgo cluster.
The things that
Okay.
say HD or the things that say Virginis, those are stars.
Virginis.
Whoa, we looked inside the Vera Rubin for a second there, didn't we?
Yeah,
That's the telescope, yeah. It's called Simeoni telescope.
So I guess
this
the
is the Vera Rubin Observatory. This is the telescope, and the camera is inside the telescope.
wow.
And it can slew really fast.
Yeah.
And okay, the days of good old silver being used in photographs are over, aren't they? It's all digital, isn't it?
Yep.
Yeah, it's all solid state.
Wow. And the scientific community is lined up trying to book. I wonder how much it is an hour to book the
They've
Vera
already
Rubin.
mapped out most of their time.
Yeah,
And
if
since
you
you can't-
apply for time on the scope, you'll be out about 20 years in line.
Since you can't get on the web, and now you can't get on the Vera Rubin, so good luck. Go with LCO, I guess.
So they're going to release all the data as they take it, if you can
Wow.
handle it.
Yeah.
How are you going to store it?
That's another problem.
Yeah.
It would cost
You
you a
suppose-
lot to store it in the cloud.
You suppose there's cities or little towns being built on the hilltops of northern Chile down in that Atacama Desert?
I think they're
No.
discouraging that.
Is
Well,
there a
they gotta
person
have
in there
they
that
gotta put these people that work these telescopes somewhere to live.
It's not that many people, and they
Yeah.
live way down on the plains.
They have big dormitories, large single buildings, and the astronomers stay there in those dorms when they are there to do their work. But most of the work with modern astronomers is not done at the telescope. The
Oh, really?
telescope, the technicians that run the telescope, aka grad students, the ones that are at the telescope. When I got a VIP tour of the big telescopes on Mauna Kea in Hawaii, we met the grad students up at the observatory, struggling. I was struggling for air, but 14,000, 15,000 feet. But the control centers where the telescopes are operated from is down at sea level at Hilo on the Big Island. And
That's
the
where-
astronomers
That's
just
where the that's where the motels to put up the people would be, I guess, the hotels.
I wish there was a person standing here so you could get an idea of this of the
The
Well,
scale.
Guys,
there's stairways going up,
Yeah, that helps
Yeah,
give you some scale.
but
So
you're not
those
gonna see
those
any-
railings are probably waist level.
Yeah,
huh.
is it facing to the left or am
yeah.
I looking at it
It's
wrong?
pointed this way.
Okay, got it. And what part of that wall opens or the part over the head right over it that we're
Yeah,
some
the
of
wall
it
opens up.
Yeah,
They're all garage doors. They open up.
and nobody has any idea how many telescopes in total are down in Chile?
oh, of course,
Lots.
they know, but I don't know.
Every country in the world is represented there.
A lot of them.
You don't get the same effect in the Sahara or the Namibian desert or
Those
The
are
Gobi-
ten-
Don't have the
those
elevation.
are those are political hotspots.
that's
Plus,
true,
they're
you're
not at
right.
high elevation, like
Right.
Bruce said.
Mhm.
Yeah.
And they're prone to dust storms.
Yeah.
Now, this
Okay,
is a
got it.
series of pictures taken by the Hubble Space Telescope that they're looking at thin and thick disk galaxies and thick disk only galaxies. So you see, this is a thick disk. The idea is we're trying to get a picture, still struggling with how galaxies evolve. What's the time frame look like as these galaxies change from one form to another? Do they actually change into each other, or what's going on? Because the time passes so slow, we can't watch a galaxy do that. So we have to look around at the ensemble of galaxies and decide, well, this one probably came first and that one came second. So the net result here from this study is that the thick outer regions of the galaxy came first, and then it flattened out to a thin tapering galaxy. So in the Leo triplet, the one that is the hamburger has a flared outer rim that's big and a smaller core. That's why it's called the hamburger. I guess that's the lettuce sticking out.
Yeah.
But so this is a stage they're looking at for evolution of the galaxies.
These are all edge on, and each one of these is a different galaxy.
Yep.
Each one is a different galaxy.
Isn't there one called a cigar? Is that one of these?
No,
Many
it's
of
not.
them.
Only
Yeah,
two.
not one of these, but yeah. There's
And Ron,
there's
you see the Z number in there? Z equals, 0.12, Z equals
Oh.
0.25.
What does
That's
that
an
mean?
indication of how far away they are. The bigger that number is, the farther away they are.
that's the redshift parameter.
Oh, wow.
Okay. And the sombrero is also like this, isn't it?
I've thought about that. It doesn't look exactly like that.
It's a
a lot of
fat
depth.
bulge, yeah.
Yeah.
Oh, so these are not big bulges. So they're probably not barred galaxies?
Very hard to tell a barred spiral from the edge on view.
Wow.
So I think we only just figured out that we're a barred spiral. But
Yeah.
we surveyed over 100 galaxies like this. They
And
develop a thick disk first, followed by a thin disk.
Boy, that last one, 3.01, that's got to be way out
Yeah,
there.
you see how faint it is.
Yeah.
Mhm.
Huh.
Okay,
But with
Check
the
the
web
diff-
now, I think we're seeing Z equals like what, 13 or 14?
yes.
Can
Oh,
you
wow.
enlarge that, please? Is it washed out? No.
No, it's
Oh.
good.
Mm-mm.
This is the constellation Cephas up near the North Pole. So this is, and Cassiopeia here. So this is pretty much available to us all year round, all sometimes very close to the horizon. But this region here is a large set of dust clouds that an amateur did a really good job of processing an image. And
That's the shark.
that's the Shark
Oh,
Nebula.
wow.
Got a couple of, it's a very, getting these
Oh, oh.
dark nebulas to show up with this much color contrast in them, I think is the
He's
A
got his mouth
plus,
open. Yeah.
A
That's-
plus of image processing. Here's two regions where the structure is illuminated by stars, but most of this is not brightly illuminated by stars, and it's not stimulated to do its own emission.
Wow.
This picture was taken by Adriano Anfuso from Wincrange, Luxembourg, and it was taken, it's a 16-hour photograph with a 4.2-inch telescope.
Wow.
So that's a fairly small telescope. Now here's the same thing as an APOD, astro photo of the day.
Wow.
A lot more structure in it. And this was taken, what is this?
Timothy Martin
It's
down in the
what?
lower right.
Signed by Timothy Martin.
Oh, yeah. No, but I was wondering what telescope,
Yeah.
Oh,
but it doesn't give the stats on the telescope.
Well, gentlemen, what a way to end with the Jaws theme. Boom, 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 boom.
That is amazing.
And what
Yeah.
it's like the 50th anniversary of Jaws, isn't it?
Yes.
Yeah, it is.
Yeah, yeah.
That's right. Well, I can tell you what movie we're all going to go watch. You did good, Mr. Prez, and so did the rest of you. Let's do it again next week. That'll be number 228. In the meantime, we're getting ready for the week of July. That'll be the week of Dr. Kaken. That's Jerry's godson talking about ingenuity on Mars. Until next week at 11 a.m., into our 5th year, I guess we'll say how we say goodbye in astronomy talk. Chuck?
Asta Nebula.